Hi there. I'm Matthew Stevenson. Unfortunately, my team members couldn't be here today for filming, but that's okay. So, we have in our possession a LEGO Mindstorms NXT robot kit, and we were asked to program it to solve an obstacle course. Now, while that may sound a little boring, we decided to spice it up a bit by modelling it after a movie character. But which movie character would you model a robot of? Rambo? Wall-E? Maybe even Buzz Lightyear? No. We decided to model our robot off that super swinging golfer, Happy Gilmore. You remember? This guy. And so our robot was dubbed Happy Gilbot. So what kind of course would Happy Gilbot solve? A golf course, obviously, but not just any kind of golf course. Happy Gilbot will have to traverse
the course of doom! Poor Happy Gilbot had a bit of a hangover incident and is now blindfolded. And he has a major golf game that he can't be late for. He has to get from his golf buggy all the way to the tee, where he must smack the ball in the next week. To get there, Happy will have to first turn away from his golf buggy, turn right to avoid the forbidden forest, avoid drowning in the Loch Ness, back up and follow the mystical path around Loch Ness. I'll keep an eye out for the Loch Ness Monster. Ooh. And avoid all of his loving spectators and smack the ball at the end of the tee.
It's a tall order, so how is he going to do it? Well, follow me and I'll show you how, with just a little bit of programming, we can make Happy Gilbot solve the course of doom.
On screen now, you can see the flowchart which we made to begin, to plan what Happy Gilbot would do. As you can see, Happy Gilbot was racing to the tee, and to get there he first has to turn left to dodge a golf buggy, turn right to dodge some trees, turn right again, and follow around the outside of the lake, and turn right to dodge some spectators before stopping right in front of the ball and hitting it. As you can see, all of this is explained on the flowchart. As well as programming the robot to turn, we also made the robot back up a bit before moving forward, as you can see here. We made the robot back up a bit before it made the turn so that it wouldn't hit the object that it was wouldn't run into. And this flowchart basically explains everything that we wanted to do. Move forward. If this happens, move forward. If that happens, turn right. We then moved on to the pseudocode, which is basically a step-by-step representation of the flowchart, with each individual motor control listed step by painful step. Pseudocode is a simplified version of the Java C code, and it is so like the stepping stone between the flowchart and the code. And now, down here, we have the actual robot C programming, or the Java C coding. And this is what is then uploaded to the robot to tell it to do. When we created the code, we had to be careful that we put in the correct characters and made sure that we didn't make any mistakes, and the robot would do all sorts of things we didn't want it to do. Just for a quick explanation, we've got here, while sensor value equals of the touch sensor equals 0. So basically that means when the robot doesn't touch anything, it's going to run forward. Then, when the motor touches something, we're going to make it back up for 0.2 of a second, and then pivot to the right, sorry. And basically that goes on, so with same thing again, while it's not touching anything, or while sensor value equals 0, it'll go forward. When it hits something, it will back up and turn right. This is called predictive coding, so we know what the course is going to be like, and so we can therefore code around it. Let's see. We made it follow the black line around the lake by putting in the light value. So if you see here, if sensor value is greater than 50, the robot will turn to the left. So that's when it senses the white area. And then if it senses the black area, it will then turn to the right. This way we can kind of get a zigzag pattern to happen, so it will continue to track the line until it hits something, which is why we've put this little code up here. So while it's not touching anything, it will continue to track a line until it hits something, in which case it will then back up for 0.2 of a second and turn left. And then down here, while sensor value of the light sensor, we've made it basically go forward until it finds a black line or the T. It'll then stop, and the little motor A is this little spinning arm, and Happy Gilbot will swing like crazy until it hits that ball.
You did it! Now, while it wasn't the biggest drive in the world, Happy Gilbot still managed to traverse the course of doom and smack that ball at the end of the tee, which is a big success in our books. So, from all the team here, we'd like to thank you for watching.
For all of us here at News Center 4, I'm Ron Burgundy. You stay classy, San Diego.